Okay, so hydrated crystals. This one over here, this is copper sulfate, but it's got water in it. And this one is dry copper sulfate. And you say, but how does this happen? Well, some ionic crystals trap water molecules between their ions when they form. I think I'm going to write that out. So some ionic crystals trap water molecules between their ions when they form. And this type of salt is called a hydrate, because it's hydrated. If you're hydrated, you've got more water in you. Okay. What's called water of crystallization. You can also call it's also referred to as water of hydrogen, but water of crystallization. So water of crystallization. Okay, water of crystallization is also called water of hydration. Now, in this hydrate, let's look at another photo. Here we go. These are the H2O. Now, it's in a lattice. Okay, salt is not only sodium chloride. It's not only table salt. There are many forms of salt. There's many forms of salt. You can get magnesium bromine, you can get copper sulfate, you can get all kinds of different salts. Okay, so it's not just the table salt that we talk about. Okay, and water for crystallization is where in this lattice, in this ionic lattice, there's water molecules trapped. Remember, we got to learn specific definitions. So some ionic crystals trap water molecules between their ions when they form. So they're trapped as they form. And you can check out videos on YouTube of hydrating and hydrating salts. So you can check it out, hydrating salts. I think the most common one will be this. What? And then how do we get the hydration out of there? Well, we heat it up, because water, when heated, pretend this is orange. When heated, obviously turns into water vapor. And so it leaves the substance, and that's how we get this dry looking salt. And you can see that this is the hydrated wet stuff. If you look at the sea, it looks a bit like this, dried out, looks like dried out salty sandy stuff. Okay, so these are H2O, these ones are H2O, and this is potassium or aluminium, and it gets trapped within this lattice. Okay, so let's look at this water of crystallization. I've got barium chloride and H2O. Now we generally write it as BaCl2 now, and a dot and 2 H2O. And you say to me, well, what does that 2 mean? It's very important. It means for every one barium chloride that I have, I've got 2 water molecules. So for every one of these molecules that's attached to the H2O, I've got 2 H2Os. But different substances form in different ratios, depending on heat and depending on the chemical reaction between them. Okay, so this becomes a ratio. In water of crystallization, this one becomes 1 to 2. In other words, one of the barium chloride molecules, for every one, there's 2 hydrogen molecules in there. Let's look at the next one. For every, can you see there's a 12 then? And we normally put a dot here. This dot in maths means multiplication. In chemistry, it doesn't. It just means it's attached. So don't multiply the numbers. It means it's hydrated in this instance. So I've got 1 to 2. Now, whatever the substance is, potassium aluminium sulfate looks like. Whatever the substance is, potassium aluminium sulfate, how many are there? Now, can you see that this is starting to happen? 1, 2. How many water molecules are there? 1 to 12. And in our ratios, we have 1 of whatever the salt is to a certain number of hydroxide ions, but let's just call them H2Os or waters. Okay, so we have a ratio of 1 to something. 1 molecule of this to that many molecules of hydrogen. And we're going to just go over how to calculate what the ratio is and how it all works. And we'll do it in steps. Okay, the fixed number of water molecules, so dihydrate monoxide, water, which are in loose combination with 1 molecule of salts. Okay, so it's a ratio. Is called water of crystallization. Examples of salt-containing water of crystallization are as follows. Gypsum or calcium sulfate bihydrate. Bi means 2 of them. So CaSO4 to 2 H2O. Washing soda or sodium carbonate decahydrate. Deca means 10. So Na2CO3 10 H2O. Magnesium sulfate heptahydrate. Hepta means 7. MgSO4 7 H2O. Zinc sulfate heptahydrate, again 7 hydrates or 7 waters. ZnSO4 7 H2Os. Iron 2 sulfate heptahydrate 7 again. FeSO4 to 7 waters. Copper 2 sulfates pentahydrate. Penta's 5. They'll often ask this in tests. They like this one quite often. Not always, but quite often. Okay, so copper sulfates, 5H2O. Salts of which are able to lose water on crystallization are known as efflorescent salts. Okay, this is just some interesting information, not pertinent to what we're doing now. Okay, so 12 waters of crystallization, 2 waters of crystallization, and what we need to do is find the ratio of the molecule of the salt that's been hydrated to the number of molecules of water in it. Okay, so there's the water is called the water of crystallization or the water of hydration. This is very important. There is a fixed ratio of water molecules to ions. In other words, the chemical formula, can you see this chemical formula? It shows the number of water molecules per one of these. Remember, if I say speed is distance divided by time. So say, for instance, I'm going 60 kilometers per hour. Can you see that hour is always going to be per 1 hour? It's the other way around with this ratio, the fixed ratio in water of crystallization. It's how many ions is 1 per lots of water molecules. And it could be 2, it could be 5. Can you see it said penta, and that was 5. It said hepta. It said deca, and it's a fixed ratio of 1 to something. 1 of those ions to how many water molecules. Okay, cool. Now, how do we see how much water is in it in the first place? Well, we put it over heat. So we can remove the water through heating because of evaporation. So let's get some orange in here, or some red. So we put it over a bit of a flame or some heat, representing heat. And this first one that looks bright blue, the water evaporates from it. So it becomes water vapor that goes into the air. And it becomes dried. And what is the dried one called? Well, if this is a hydrate, this is going to be called not a hydrous salt. It's going to be called I think I should have called it anhydrous, but anyway, anhydrous, an anhydrous salt. And please write this in your books as notes. It's very important if you need to write those notes. Okay, so anhydrous salt means it's dried out, means there's no more hydrous, there's no more hydrogen, oxygen, hydrogen monoxide in it. There's no more water in it. Okay, anhydrous salt. And we do that through heat, so we can get the water vapor. Now, we often want to know in moles, because we're working with moles now. We're not working kilometers, centimeters, let's think, kilometers, centimeters, kilograms, pounds, miles. We're working in moles. So we want to know the number of moles of water that was in this solution. So say, for instance, and this is most common, this copper sulfate, and I've got 5 pentahydrate, copper sulfate pentahydrate. And this means I've got 5 molecules of water for every copper sulfate. So it's a 1:5 ratio. But say, for instance, I'm picking out strange numbers now. Say, for instance, I had 100 grams of this hydrates. I have 100 grams of the hydrates. I apply heat to it. Water vapor, the water escapes through water vapor, and then I've got of this light colored sandy looking dried out substance. Looks like someone's bones dried out, and what I've got left is 55 grams of it. Well, what's your deduction? Well, if I've got 55 grams of copper sulfate left, how much water should I have had? Well, 100 of the hydrates, so the dark blue, or the darker blue, minus the 55 that escaped through water vapor, gives me 45. So my copper sulfite, and this is not a great example because it should be 1:5. But my copper sulfate would have been 45 grams. And that's called anhydrous salt that's left over, which means, of 55 grams of copper sulfate left over, which means that the water weighed 45 grams. So I had 45 grams. Now we've got to turn that into moles, but let's get a better, an actual formula, not something I made out of my head in the moment. Okay, so we're going to take hydrated calcium sulfate, which is CaSO4 2H2O. That's a solid. And I'm going to apply some heat to this. This is a flame. And I've got some anhydrous. Can you say anhydrous? Not anhydrous, but anhydrous, meaning I've taken the water out of it, the hydro out of it. Anhydrous calcium sulfate and the water, which is going to be in gas form. So what have I really done? I've caused the anhydrous salt, which is a salt with the water of crystallization removed. So you can write that. So water of crystallization is removed, but I want to find the number of waters of crystallization. How do I calculate the number of waters of crystallization? Well, I find the ratio of moles of water to moles of anhydrous salt. So anhydrous salt can be AS, anhydrous salt, anhydrous salt. I'm hoping it's spelled like this. Anhydrous salt. Sometimes I put some O's and some U's where they shouldn't be, but I'm sure it's spelled like that. Moles of anhydrous salt. The ratio of moles of anhydrous salt to moles of H2O. And how do we do this? Well, we use our nice good old friend. Number of moles is equal to M over M. Okay, and we're going to first find this. And some teachers will say first find the anhydrous salt and then the H2O. It doesn't matter what order you do it in. I'm going to do it in this order. I'm going to find the H2O, the number of moles in water. So I'm going to take, then I'm going to take M over M of the anhydrous salt. And with those two, so let's make this into steps. So with those two, I'm going to have step 1, find the H2O. You can find it in 2 different calculations. It doesn't matter which one you do first, but of H2O and then anhydrous salt. And how do we see how much in mass we have of the H2O? Well, after it's been, I want to say dehydrated, after the water's been taken out, what was my beginning weight and what was my end weight? That tells me how much water was taken out. So that's what mass you're going to use. So in steps, we're going to go find the number of moles of water, then find the number of moles of anhydrous salt. Then after that, we're going to determine the ratio of water to the salt. So I'm looking at a ratio. If I've got a ratio, and say for instance that I found out that this H2O was, I don't know, 0.5. We haven't taken something specific now. So 0.5 to 0.866. Okay. Now, what do I need to have? On the left hand side, I need to have a 1 to something ratio because I've got a number of molecules of H2O. And please, this must be, very importantly, this is going to be an integer. So it's not going to be 1,66 or something. We're going to round it up. And sometimes we lose a few decimals at the end of 10 decimals. And so it hasn't, sometimes we just have to make up for that and round it up. As part of our calculations, but we're going to round it up to an integer. Okay, so we need an integer, in other words a whole number, a 1, a 2, a 3. We're not going to have 5,657 pi. Okay, so if I've got 0.5 to 0.866, now these are just numbers I thought of out of my head. How do I get a 1 here? Well, I divide by itself, 0.5. But what I do to the one side of a ratio or a fraction, if I've got this and I times by 2 over 2, what I do to the top, I do to the bottom. The same with the ratio. What I do to the left side, I do to the right. So I need to divide both sides by 0.5. And that will give me something that looks very much like a whole number. Let me quickly put it on my calculator and see what it says. I just made it up, so it probably doesn't say something perfect. Okay, let's put a 9 here. So 0.9866 divided by 0.5. Now, can you see this was recurring? So I kind of rounded it up or down because these 6's would have carried on forever. So I've got a number here, 1. Remember, I made this up as well. So I've got a number of, this is equal to 1 to 1,972. Now, you have rounded off a whole lot of decimals at the end, and this looks more like 2. So you're going to literally put 1 to 2 because there are a few little decimals here that we missed out. With a lot of recurring numbers, we miss out the last decimal. So we're going to round this up to 2. So for one of whatever this molecule is, I'm going to have, whatever this salt is, I'm going to have 2 waters of crystallization. Okay, so then you're going to write the formula as soon as you find, and as soon as you do this, let's put in a step here. I want to say integer here. And you're going to round it up in between. So you're going to say 1, 2, 2 waters of crystallization. 2 waters of crystallization. And then we put it into a ratio. Now, as soon as we've put it into a ratio, say for instance, it won't be this. I'm just thinking something up. Hydrated calcium sulfate, CaSO4. And we put this number into 2H2O. And this number can either be in a formula in your exam or test. It can be like an X as a variable. Or sometimes they put in an N. It's usually an X. Okay. And then you're going to write out your formula. And this is going to be your formula. But don't try and balance it with doing stuff here, because this is the simplest ratio. For every 1 CaSO4 I've got 2 H2Os. Okay, so that's the simplest formula. And it's always a whole number. Please remember, water of crystallization is always, I'm going to write it here. Crystallization is always is always a whole number, because you can't have half a molecule of water, because water is 2 H's. There's a big O and there's 2 H's on it, like a Mickey Mouse or a Minnie Mouse, and you can't have half of a water molecule. That's like saying, well, it's like an H, it's no longer dihydrogen monoxide, it's monohydrogen, which is not water at all. Remember, substances can't be half molecules without changing what they are. Remember, if you take NaCl, and that's table salt, and it's harmless, it's just throw it over whatever we're eating. But if you take sodium by itself as a metal, it is very volatile before it bonds with chlorine, with Cl. It is very, very volatile. And so if it's not reacted, if the electrons haven't reacted properly, and there's a sharing of electrons and different things are happening, this can be very volatile. So I can't have half of an H2O. I either have 2 hydrogens and an oxygen, or I have some other weird lattice or some other weird molecule, which could be dangerous. So it has to be a whole number, or it's a different molecule altogether, and you could be dealing with the beginnings of some kind of hydrogen bomb or something. Okay, so here's an example. The anhydrous salt, aluminium trichloride, tri meaning 3, so there's 3 chlorides. So I've got AlCl3. Okay, is a catalyst. Now, very interestingly enough, a catalyst helps things to move along quickly. It's not quite a catalyst, but if I've got to glue something together, just on the fly very quickly, I'm going to take some super glue, and I'm going to quickly glue 2 things together quickly. And quickly glue them together, but I want that thing to dry fast, and so sometimes I put some baking soda, or or bicarb of soda, I put some bicarb of soda onto whatever I've glued together so that it's a catalyst to make that thing drive very, very fast. Okay, so catalysts help chemical reactions to react better, faster, and I suppose more. So that's what a catalyst is. Okay, a catalyst can also start the chemical reaction as well, which is quite interesting, but it usually speeds up or increases the rate at which a chemical forms. Okay, just interesting. In the manufacture of chemicals, the salt forms the hydrate, aluminium chloride, trichloride, aluminium trichloride, H2O. Okay, this X represents a variable. We don't know the ratio yet. When 10 grams of the hydrate is heated, 4.47 grams of water is driven off. In other words, that's water vapor. Okay, and then it becomes dry. Okay, how many moles of water of crystallization is there in the hydrate to begin with? So let's see. Number one step, we're talking with moles. First thing we're going to do is, obviously, we're going to say 10 grams minus the water that's driven off, the water of 4.47, gives me the anhydrous salt, which looks like it's 5.53. Am I right? I think it's 5.53. 5.53 grams of the anhydrous salt. Okay. So we have the amount of water and we have the amount of salts. Well, that's interesting. Then we're going to calculate the number of moles. We're going to say N is equal to M over M. So we're calculating number of moles. Let's see. Over here, O is 16. It's very wise to learn the stuff off by heart, the smaller ones. So H is atomic numbers. We've got 1, but we've got 2 of them. So I've got 2. N is equal to, I've got 2 times 1 plus oxygen is 16. Okay, so it's wise to learn that stuff off by heart. Okay, and then how many grams in mass do I have of water? I have 4.47. So I'm going to say 4.47 is moles. Remember converting, I don't know what the conversion is from kilograms to pounds or pounds to kilograms. The pounds, what they use. Oh, and the Brits, they also use stone in terms of how much their bodies weigh. So I don't know how much stone there is and how many kilograms in one stone, or how many pounds in a stone, or how many pounds in a kilogram. But it's just a different measurement according to our carbon 12. Well, according to our chemistry. Okay, so 4.47 divided by 18, which would be, let me quickly turn this on. Okay, so it's 0.248. Please remember to put here moles of water so that you're not getting these ratios mixed up and thinking that this is the AS. So the next thing we got to do is, remember in grade 10 they love formulas. So write out your formula. You get a mark for the formula, get a mark for the substitution, get a mark for the answer. Okay, so little m over mm. And now what are we working out? We are working out this anhydrous salt of aluminium chloride. So I'm going to say N is equal to, now what was my grams in mass here? It was 5.53. So I got 5.53 grams. Again, I don't know how to convert from pounds to stones to whatever, but we do know how to find number of moles by the mass in grams divided by our periodic table relative atomic mass. So relative atomic mass, aluminium is 27. just want to check. I think it is 27. Yes, 27 plus, and how many chlorides have I got? I've got 3. Please put in here 35,5. Okay, so 3 times 35,5 plus that divided by that. Let's see. Okay, so I've got 0,0414 moles. You want to about 4 decimal places so you don't lose a lot of that number. Remember, integers. We need integers of molecules of H2O. We can't have a half a molecule. Okay, 0.0414 moles of this stuff. Okay, or you can say of the AS. I'd rather put it as aluminium chloride. Okay, so now we've got to go, okay, we need the ratio of the anhydrous salt to the water. So I'm going the anhydrous salt to the water, and you can say here AlCl3 to H2O. And what have I got? I've got 0.0414 to, what is that? 0.248. And this is in moles because we're in chemistry and that's what we're working in from now on. Okay. In terms of our chemical molecular substance. So we're going to divide both sides, 0.0414. Now, there could have been rounding off here. There could be lots of rounding off here. So if I don't get a whole number, you go as close to that whole number as possible and get to that whole number, because we could have rounded some off. Let me quickly do on the calculator. And my calculator says if I divide this side by that side to get 1 by 0.0414, I'm going to get 599. But can you see that there could have been some extra things that we rounded off before the time? So this is going to be 1 to 6. But am I done yet? No. I need to give the formula. The last step is you need to give the formula. So now you've got the ratio. For every 1 aluminium trichloride or aluminium chloride, there's going to be 6 water molecules surrounding it in that, or part of it in that lattice that we saw at the beginning. So here we go. You're going to write the formula for this. So it's going to be, let me just write AlCl3 2. Oh, but no longer 2. We're going to put a dot there. Dot. And I'm going to say, well, what's my X value? 6 H2Os. Okay, 6, and 6 is hexa. So this thing should probably be called aluminum trichloride hexahydrate. I think it would be called hexa. Hexa is 6. That's why you got a hexagon. And please, it's always a whole number. Please write it again and again and again. Okay, so the water crystallization is always a whole number. I'm not splitting that water. I don't want to say it too loudly on YouTube because I don't want to be flagged for for strange things. But they split the atom for nuclear fusion. They split the atom. And it's where something very unstable like uranium is taken, and the nuclei, the neutron, it's like split. I don't want to say too much and then I get flagged. It's like some kind of bomb person. But so it's got to be a whole number, because we're not going to make some kind of new hydrogen bomb or something like that. We're not gonna we're not gonna release neutrons and strike and split unstable atoms and all sorts of weird things. We need a whole number. It's very interesting. Look up how nuclear fusion is made, or how they do it. And it's very, very energy. It creates a lot of energy. but a lot of radiation as well, so you got to be very, very, very careful. It's not like coal energy. So there we go. Okay, so you're going to do one by yourself and write it in your book, and then check the answers and check to see that you went through the correct process for the answers. Okay, so 15.67 grams total of magnesium carbonate and so many water molecules. Producers could be hepta, could be deca, could be hexa, penta. We'll see where it goes now. Producers, anhydrous, remember what's AS? It's anhydrous salt. Please remember that. Anhydrous salt. If they say to you, what is anhydrous salt? It is a salt that's been dehydrated, or salt where it's been dried and the hydrogen has been taken out of it. So anhydrous salt. Okay. Produces 7.62 dried magnesium carbonates. Okay. What is the formula of the hydrate? So what is the process you're going to go through? You're going to find the weight. This is of that dried up salt. Dried up salt. You're going to find the weight of the water. Then you're going to find the molar mass of the molar mass of that water, the molar mass of the AS, the anhydrous salt. Then you're going to put them into a ratio and make the left hand side equal to 1. So it's going to be 1 to something. And you're going to do that now and then check my answer after. Okay, you should have done this step by now. Very easy. You take the whole, you take the dried, and therefore this is the water, or the water vapor. This is grams. Okay, pause the video and carry on. Okay, so calculate the moles. I'm going to take the mass divided by the relative atomic mass. Know that this is always going to be 18 because one hydrogen, which is 1 and times 2, one hydrogen is relative atomic mass of 1, so 2 of them plus an oxygen relative atomic mass is 16. You're always going to get an 18 here at the bottom. Always going to be an 18 for H2O. Okay, 0.45 mole of H2O. It's now water vapor, but we're trying to find the hydrate. So before we heated that thing up. Okay. Okay, so number of moles is the mass divided by the relative atomic mass from your periodic table. Magnesium, it's good to remember the magnesium is 24. It's good to remember carbon is 12, and it's good to remember the oxygen is 16. It just saves you a bit of time, I suppose. 84, which is 0.0907 moles. That's the H2O. How much moles of it? Pounds, stone, kilograms. It's all different measurements for the same thing. Okay, so now I need that in a ratio. So my calculator says 4,9614, but remember we could have rounded some of this off. Some of the things were rounded off in your calculations. And so this is going to be a whole number, so I'm going to round it off to the top whole number, which it should be actually, without all the rounding offs. And so I'm looking at 1 to 5. So that's my ratio, but am I done yet? No, I'm not, because I need my formula. So I'm going to have MgCO3 dot, remember this doesn't mean times, it's the ratio, 5 H2O's, and that's my formula. That's about 5 or 6 marks, sometimes a bit more depending on how many formula marks they give you for just writing out your formula at the top, these basic formulas. So what is this really called? Magnesium carbonate 5 is pentahydrate. Okay, so that's really interesting. So that means for every 1 molecule of magnesium carbonate, there are 5 molecules of water. And we see this here right at the beginning. If these are not K's, if these are, what have I got? What was it? MgCO3. Well, that would have been Mg's in there and CO3s separately, but because these SO4s would have been CO3s. For every one of this magnesium carbonate, there are 5 H2Os. There's 5 of these guys. 1, 2, 3, 4, 5. And let's pretend this, well, magnesium is not really, it's not really yellow. That's more of a sulfur, but anyway, possibly. And 1. Then 1, and we're pretending now. 1, 2, 3, 4, 5. We're pretending that these things without the purple balls are the hydrogens. So 1 magnesium carbonate to every 5 hydrogens in this lattice. So let's just go over some important points. So some ionic crystals trap water molecules between their ions when they form. They form when I heat it up. It becomes an anhydrous salt. Before it's heated up, this guy is called a hydrate because it has water in it. It's got water crystallization. There's a fixed ratio of water molecules to ions. The water in that lattice is not just called water, it's called water of crystallization, sometimes water of hydration. And we were to check out what the ratio of the compound or the salt to the water in this lattice is, we remove the water of crystallization through heat, and we calculate the number of water of crystallizations by the before and the after masses. Then we've got to find the moles of each substance, and we put them into a ratio, and the water crystallization is always a whole number. Okay, good job.